Then they like later on after the finance report. I forgot what we were talking about, but I guess we are trying to compare thingy XS. So all we need to do is um to put in the XS table. So when you're prioritizing, if data is in this predefined, then just do the access thing. The index is this, then you get then you return, then you use the access function, not in the access. Then it does this. Then you do this. Wait, don't cancel. Really? No, I don't. You have strong opinion, do it. I have strong opinion. It's fine. Okay, it's 3.1.
Hello.
Good morning.
Good morning.
Morning.
Hi, Shane. Hi, Mohammed. And Nevin,
Hi.
I heard you earlier. Okay, good. So why don't we just get started and see if any of you have some questions and of course updates from your side. Mohammed, would you like to start?
Yeah, sure.
That means you need to share screen.
Yeah.
Okay, got it. You should have that option now.
Okay. So yeah. Yeah. So these are some like new results for federated GANs. So as you know, like we have like three approaches: FedProx and FedAVG and SGD. So the red one is the SGD and the green one is FedAVG and the blue one is the FedProx.
Okay.
So it seems like, yeah, so I have put like these are like all new results. The FedProx are the previous one. So here I'm like waiting the alpha. So it seems like at like 5 to 10, like in overall, like the DP FedProx GAN is like outperforming other FedAVG and SGD. There are some points like at very small epsilon value where the other like FedAVG is performing well, but it is just like at very low alpha value, the other ones.
Oh, you meant to say when alpha is very small.
Yeah, at very small alpha values. For example, here, like
Yeah.
the FedAVG is performing well as compared to FedProx. So, but there are very few examples where the other ones are performing well. But overall, if you see in this portion,
Yeah, but
yeah.
we should compare solid line with solid line, right?
Yeah, yeah.
So
Yeah,
you
yeah.
can see that if it's a solid, if you compare the green solid line with blue solid line, then there's no issue.
Yeah, yeah.
Because they represent different distributional settings.
Yeah, in that case, yeah.
Okay, yeah, so this actually confirms, right, our choice of using FedProx is much better for the skewed setting.
Yeah.
But even in non-skewed setting, it seems to perform well. That is also interesting.
Yeah. And yeah, the FedAVG is not converging well. It needs like more iterations. But our privacy budget is like under 100. And
so I guess also the reason is here is we have each party has a large number of data. So for sure, even if the alpha parameter is kind of higher, for sure between different parties, the data still differs. Between them.
Yeah. That's also the issue.
It won't be as a simple case as the plain FedAVG where they only try to train on a few samples for every user, right?
Yeah.
Yeah.
That's another issue because we are not running like more. We are not running any epochs local data. It is just like we are selecting some samples and then we are running gradients. So that's why it is not like converging. And these are results for the white book attack accuracy. And this is the same setting, the one I showed you on the previous slide. Here, like I'm weighting the alpha and 3 federated GANs, and the y-axis is the white book accuracy, and the x-axis is the alpha. So, but I see like there is not much difference. There is a little bit difference, but not much difference. For example, if you see between SGD and the blue ones, there is some difference, but if you look at this chart, but the inception difference is also very large. This is around 8 to 10 inception score difference. So, but I think so we can plot on just like privacy versus utility trade-off. I think so where we can see these things better.
Yeah, that is a good point. But I also wonder why in Amnesty data sets the trend is different. So it seems like for all other data sets, when you have higher utility, you also have higher privacy risk, right?
Oh, let me check it. I think so. This one. Right. Sorry. Yeah, I think so. There is one, like, I can put the figure here. Sorry.
Oh, okay.
So, yeah, this one. Yeah, so this is the picture. I think so. I put the
okay, yeah.
FID one. Yeah.
Now it's a kind of expected. So utility and privacy always kind of go hand in hand.
Yeah, but I will check it. There is another issue. Yeah, I think so. This is the one. Yeah.
Yeah,
but
it
there
is
is not much
interesting
difference.
that
Yeah.
in one setting you have lower performance, I mean lower accuracy, but also have higher lower IS score, but higher privacy risk, which is the dotted line, right?
Yeah.
So the dotted line seems to have higher privacy risk,
Yeah,
but
it's a skew one.
lower IS.
Yeah. The quantity skew.
Quantity
It is
skew.
because because in for the attacks we have just like small amount of data set, and if one party has more data set, then that party will dominate and will learn more about the GAN model. And it is more prone to the white box accuracy. And this is a similar trend we observed before as well. If the party has more data set, they are more vulnerable towards the membership influence attacks. In all settings,
no, I wonder why the utility perspective for the dotted line utility is always worse than the solid line, right? I think that's what we observed in the previous slide.
In which setting?
Oh,
Here?
no, actually
it's a different
above
one.
the solid line. Oh, okay.
Yeah, it's above it.
Okay, then it's expected, right? So if they learn better, if the models learn better the local data, you will have better IS, but also higher privacy risk of those local data.
Yeah. And this is one like where I'm weighing the privacy parameters, and these are like three GANs. The ones I showed you previously, the federated GANs, the FedProx, and the FedAVG and FedSGD. So this is basically the first three columns are for IS, and then we have 3 for FID score. Yeah, and these are like 4 data sets we are using. So as a like in the FedAVG, the quantity QLI setting is not performing well. It is the lowest usually in these 3 data sets. Yeah, but there is not much difference.
Like, you're right. I think it does seem like for DP-Fed-Prox and DP-Fed-Average, non-skew is often performing pretty well, right? They often perform very well in non-skew setting.
Yeah.
Which is also why we observe like increasing alpha, they achieve the best utility.
Yeah. That's true.
But once we align the privacy between DP-Fed-Prox and DP-Fed-Average, utility-wise, Fed-Prox is always better.
Yeah, it's always better.
最近我身边就有几位朋友遭遇了杀猪盘，除了几千到上万不等的财产损失，还有无法衡量的情感损失。诈骗团伙一般身处境外， 伪造身份
model
信息，并通过
updates
各
or
种社交平
local
台寻找对象，
kind
假
of
装不经意间相
iterations.
识或搭讪，等确立关系后，
Yeah.
再用投
We
资
have
生命等
in
借
Fed
口
proxy
骗取
and
资
Fed
金。
AVG, we
这种
have
先养
local
后杀的诈骗
iterations.
手段，
That
被
does
称为
not
杀猪
count
盘。
the
杀
number
猪
of
盘有一套
rounds,
严谨的
right?
话术流程，通过心理学侧写对受害人进行专业 PUA， 具有规则
Yeah,
化、
so I
模式
think
化的
that
特点。
actually
俗话
incurs
说
more
要有魔
cost.
法打败魔法。近几年，
Yeah.
人工智能在模式对话
From
方面的
a
进展
privacy
并不弱于
perspective,
AI 绘画，
because
得益于大规模预训练模
you
型
have
技术的
to
进步。
compute
国外
too
甚
many
至已经有不少
times,
误以为 AI 产生人格的案例。这次我基于最新的开源模型，开发了一个能够无障碍进行微信聊天的人工智能，并在与骗子的真实对话场景中进行测试，试着观察 AI 如何与骗子斗
Like
智斗
weighing
勇
the。privacy
虽然之前我已经
parameters
开发过
the
不少
same
AI，
setting
但大多都是
on
集中在文本
the
创
one
作
I
上
used in。
在评估了之前我开发的几个 AI 的对话性能后，我不幸地发现，由于缺乏知识图谱和 QA 设计，他们说起话来都像个智障。
Yeah, this seems to be quite consistent. Attack
不
wise,
过
so
办法
you're
总比
saying
困
that
难
the
多。
Fed proxy
上个月我
seems
在
like from the
GitHub 看到
result,
过一
Fed
个很有
proxy
趣的
does
项
not
目
incur
AI
much
剧
higher
本杀，
privacy risk.
里边就用到了目前国内为数不多的开源预训练多人模型源 1.0。 开源就意味着不用再从头到尾的训练一遍，
Yeah, not
所有
much
能力
more,
可见
but
可
have
复用。
better
而为了评估
utility.
模型的可用性，我特地去看了它的源代码和论文。
That is a
简而
good
言之，
message.
为了更好地达到通用语言能力，这套中文模型的单体参数量达到了2400亿，这意味着模型的表达能力更强，训练数据也达到了5000 G， 基本涵盖过去5年中文互联网所有的优质文本知识。从结构、数据和参数量上，它已经完全满足了我对 AI 对话的基本要求。而搞定了模型，一个新的问题又出现了：微信聊天是多轮对
Yeah,
话，
maybe
而
first,
AI 有时
yeah,
并不
like
记得
it's
自己
like
或对
you're
方上一
doing
句说
right
了什
now.
么。
You put all the results in this PowerPoint, right? So it's easy for us to reference.
你呢？
Kind of like a
王小贵。
booklet. What are the experiments we have ran?
你叫什么名字？
And then when
为了解决这个问
the
题，我参考
review
训练模型中
notification
LSTM 的思想，
comes,
为系统增加了递减
at
机
least
制，
we
让
can
AI
quickly
能够
go
实现
through
简单的
these
短期对话
slides
记
and
忆，
find
比如
out
昨天
what
聊过的
are
内容或上一轮
some
对话
new
的内容
results we。can
此外，
insert
我还
or
为 AI 加入了一
replace
种基于 Prompt Example 的
in
先
the
验规则，
manual.
引导 AI 来针对性的学习如何说话
Yeah, I think， this
尤其
is
是在给定诈骗场景的任务下，俗称看菜下饭。这里的 example 语料主要抽取
Yeah, all
自
right,
B 站和贴吧的
thank
热门
you.
评论，一来是因为评论是天然的对话形式，有显示的回复与被回复关系；二来自古评论也多出了
Any other
一些金句。
questions or requests from your side?
Not right.
Oh, okay. All right.
I'm good. Yeah, thank you.
All right. Yeah. So maybe next one up, we can ask Nevin to share some updates. But Mohammed, I also Nevin and I were discussing about a particular inference or attribute inference, privacy leakage on a medical imaging data set. So perhaps you can also listen and see if there are some kind of a baseline privacy attack we can perform on the medical imaging data sets.
Okay.
Yeah. So let's see if Nevin first have something to discuss.
Yeah, Professor. So after our last meeting, I did not actually get time to look into further
句和梗
updates.
可以把人机对
So
话
I'll
变得不那
be
么轻易。当
wrapping
然，
this
它的
up
效果也
with
出乎意料。最后，
baseline
我使用开
model
源的 WeChat
with
框
the
架，在云上搭建后
discussed
端，
gradients
基于本地的
structure
Python 脚本
and
调
a
用巴菲的
classification
服务，让
model
AI 无
for
缝
that.
接入微信。只要
So
登录预先注册好
yeah,
的微信
Mohammed.
号
So the
，AI
basic
就可以
idea
回
is
复任意
that
私
we
聊
will
或群
be
聊了。为了
extracting
保证 AI 足够拟
the
人，
gradients of
我还
each
做了
of
如
the
下设
images
计：
trained
发布
to
以假
detect
乱
a
真的朋友
particular
圈，
disease.
设定每条信
And
息的
for
回复
each
间
of
隔，
these
模拟
images,
真实
we'll
打字
be
速度，
having
加入通用表情提供关键
particular
词，
we'll
但
be
目前
having
还不支持
particular
表情包。
attributes like the
连续
gender,
句拼接，当对面说了多段话时
the
，AI 会
age
读取成
group
一句
and
话
all.，
只回复一次。
In
为了让
from the
骗子上
IDLG
钩，
paper,
我在多个
we
社交
can
平台注册
already
了账号，
infer the
然后根据
labels
公安
from
部
the
和
gradients.
反诈中心发布的
So
受害者画像，为
detecting
账
the
号定位了
disease
单
won't
身、
be an
多
issue
金、
from
高学
the
历、高干女
gradients,
等
but
身
we
份
are
标
thinking
签。
of using
果不
the
其然，私
gradients
信
to
爆炸。为了避免误
identify
伤，只有同时
things
满
like
足以下几点
gender,
的人才会让
age
AI 接
group
管
and
对
things
话，
like that.
比如人设背景完美但
Which
关键
can
信息
be
模糊，
like
照片确认为网图
attributes of
可在
the
网上搜到，
image that
同时如私募、
indirectly.
投行等高端行业
So
需要
that's
低
the
调人
idea.
设。微信转账、验证银行卡实名和名字不符等等
Yes, yes.
经过一系
So
列
you're
过滤，
basically
最终有5位嫌疑人
predicting
脱
the
颖而
labels
出。
using
他们与
gradients,
AI 的对话
right?
过程被全程记录。时间
That
关
is
系，
the
这里
idea
我
of
仅挑选一部分对
IDLG.
话
That is
进行展
already
示。
done. So we are checking if we can also infer some indirect details from the image, which is not directly linked. So if we get the image, can we get the gender of the person or say the age group of the person? So instead of using the image, can we do that using gradients?
I see.
Yeah, that's a good summary. So Nevin, do you happen to have the link that I shared with you last time to the data set, the high resolution data set?
The Kaggle, the NIH.
Yeah, the NIH one. Yeah.
Yeah, I have that link.
Yes,
Let me-
please.
And also,
Mhm.
do you have some ground truth labels as well?
Yeah.
For example?
Yes. Okay. In the data set, there will be. So yeah, in each image, you would have the disease label, right? For sure, that is the thing that the deep learning model is trying to predict. But I think our hypothesis is that deep learning learns unwanted, basically, right? This is unwanted learning. So actually learns more than needed to learn. So perhaps during this representation extraction, these deep models try to also kind of distinguish or discriminate some other attributes, for example, identity, gender attributes, age group attributes. So we're trying to understand, first of all, if in the federated setting, right, where the gradients are kind of shared, can the attacker, right, using Nevin's work, right, can the attacker infer these other attributes that is unwanted through the shared gradients? But I also wonder that if you could also look into this data set and see, just in the planning setting, like if you just have the image, how accurate can we predict those attributes? So that can be a baseline, right? Risk. Right. So if we have the risk that, through Nevin's work, we have the risk of those attributes inference at a certain level, but then we need to be able to kind of quantify how is this risk level high or low, compared to what? So maybe it's what, right? It should be a baseline risk of attribute inference, which can be maybe conducted by just building classifiers on this original input image, right? Try to predict gender.
Yeah. Sometimes people also use like some KNN classifier. For example, if I have some like information regarding some attributes for a particular record, then I will compute the like distance between this point to the other point as well in the training data set. And the points that are very closest to this record, I will like assign that particular label for the attribute.
Right. Yeah. So if you have some similarity metric, and you can use this KNN as a classifier. But I do think our hypothesis is that deep models learn more than what they are told to. So I wonder if we could just run some quick deep learning-based classifiers on the input images to really understand the baseline risk. Like, is there a baseline risk for leaking these gender information and age group information?
3 weeks later.
Nevin, do you have the link? If you could paste it in the chat.
I sent it via mail.
Oh, okay. Yeah, not a problem. Yeah. Sorry, I wasn't clear. Okay, so that should be in in our mailbox. So yeah, the NIH chest X-ray data set.
Okay.
Yeah, and I think what I find interesting is this NIH a high resolution chest X-ray data set was actually used to create MNIST style chest X-ray data set that is incorporated in MedMNIST. So I think they are trying to rescale or resize these high resolution images into smaller size, right? MNIST style images. Still, as a benchmark to test deep learning based disease, right, classifiers. So I think maybe there is interesting kind of investigation to be done on the amount of information leaked from these high resolution images between high resolution and low resolution. So I think I'll follow up this same mail and paste the MedMNIST data set that is kind of created using these high resolution chest X-rays. So they actually reduce the resolution very much from around 1000 pixel width and pixel height to 28 by 28 pixel width and pixel height. So I think it's an interesting investigation to kind of think about how much information as well as private, right, or sensitive information can be removed, or right somehow can be removed from these images. Can we come up with some better resizing operations? And those are some just intuition. If this lower resolution images can still be useful for deep learning, then I think that could be a good utility metric.
Yeah. Yeah, I will look into this one.
Yeah, so yeah, I'll follow up with that. Yeah, thank you, Nevin, for the update. And I think it's a good thing that the two of you can try to contribute to the same kind of idea, but from different angles. So Nevin, you can continue to build this gradient-based attack, and then once we have the attack results, we can compare with the baseline privacy risk that can be measured. If Mohammed can come up with some baseline, attack, just not attack, but baseline classifier, just based on the input images itself, then we can, make a kind of statement whether this gradient-based leakage is higher or lower than the baseline leakage. Does that make sense to you?
Yeah, Professor.
Yeah, okay. So let me see. Yeah, so I don't have a group meeting next week on the calendar. Is it okay if we get together and see if there are any development this week?
Yeah.
This week, Thursday?
No, next Tuesday, sorry, all together.
Oh, okay. Yeah.
The same time?
Yeah, it works.
Okay, great. Yeah, all right, I'll extend the calendar invite so it'll go on your calendar. All right, thank you.
Yeah, thank you, Professor.
Thank you.
Yeah. Okay, let's see. I think Tanusra emailed me and she has some conflict today for exams. But let's move on to the undergrad students. Ashley, do you wanted to say a few words?
Yeah, just still working on the implementation. Yeah, I didn't get too much time to work on it because of the finals wrapping up and stuff, but yeah, I think I'll probably work on it more like later in the week, and then a little bit during the break too, of course.
Yeah, so my suggestion to you is try to give yourself a breakdown of tasks, right? For example, let's say one day you wanted to be able to define all the variables, right? Like I said earlier. So, and then the next day you wanted to be able to write, constraint, the first constraint, or, the first set of constraints that define the probability density functions.
Yes.
Right, so give yourself some, easily decomposed tasks, and then create a timeline to achieve your goals.
Yes.
Okay, that's okay. So if you have time next Tuesday, you can also join us and we can see if there are any development on your side.
Okay.
Or questions, right?
Yes, that sounds good.
Yeah, okay, great.
Right, thank you.
Yeah, let's see. Shane, do you have new questions or updates from your side?
Yeah, so I did what we were talking about last time.
Yeah.
Do you want to like oh, can I share my screen here?
Yeah, go ahead. You have the button? Yeah.
All right. So I make it so that it will need to so add this condition.
Advertise.
So if the data here is in XS, then you do the XS function. Otherwise, you do XN.
Okay. Yeah. So XS is defined in the domain rather than index, right? So basically, let's say that if XS is categorical variables, your index is, how do I say that? XS define the data values that is in the sensitive set, not the index positions of the sensitive values. Do you see what I'm saying? So yeah, I'm just trying to understand whether we should compare data to XS or index to XS.
Yeah, that's also what I was thinking. I don't know, like because the index may
so index could be 0, right? But in your domain, you might not have 0 value, right? So that's the difference. In your domain, you could have values from 1 to 8 in your example, right? But your XS should be maybe defined based on the values in the domain. So let's say 1 to 4. But the index correspondingly to 1 to 4 would be 0 to 3.
Yeah.
Do you see what I'm saying?
So you just kind of just unmap it, I guess.
No. You still inside this function, you still have data, you still have index. You just need to make sure when you pass the XS and XN, you need to make sure that it is consistent with your comparison. So if you compare data to XS, and then you need to make sure that your XS is defined over data.
I
not
see.
over index.
So
I think it's when you call maybe or in your example or something, right?
I probably just put this define this as the XS. So this should be data, right?
Yeah, this whole thing should be data.
Okay.
Yeah.
So now I can just put this into here, and then.
Yeah. When you call it, when you call the client, you have to pass the access. Yeah.
Okay. All right. So now I.
Okay, so that seems to be okay. Yeah. So you call based on where the data value falls in, you decide to call whether it is use the probabilities associated with sensitive elements or use the probabilities associated with non-sensitive elements. Yeah, I think it's good.
Yeah. But before testing it, I still need to look at the server first, and so that I can try it out. And so still this part. Should I read the paper you mentioned last time?
Yeah.
I forgot what that is. I think it's 19. Wait.
Distribution estimation. Oh, discrete distribution estimation under local privacy. Yeah, it's cited there, but this is the title. I just pasted in the chat box. Yeah. So we're talking about the empirical estimation. You wanted to look at the empirical estimation under K-rapport. Oh, paragraph. This is the title. K basically is the domain. So like the number of, it's D in your case, is in your code, is D. So that represents how many values you have in your domain.
Oh, I got it. I guess my next step is just to do the server part and see how it goes.
Yeah. It's the update the estimate. Yeah. Use some smarter ways, not just counting how many people report that particular value, but if you know the probabilities, right, of how an input is mapped to an output, then you can use those probabilities to formulate a educated guess. Yeah, so that's what this empirical estimation is about. They try to correct the aggregates using those probabilities associated with randomized response mechanisms.
All right.
Yeah, it's good.
I see.
Yeah, sure. So if you come across questions of reading this, we can talk about it next week as well if you have time.
Yeah, sure.
Good. Yeah.
All right, thank you.
Yeah, thanks, Shane. Yeah, thank you all again. I think we can wrap up over here and let you guys move on with your finals or projects and papers. And I'll extend our meeting for another occurrence next Tuesday at the same time, and then we can all meet up again to kind of, as a conclusion to this semester's work. Okay, so I look forward to talking to you guys all together next week.
Thank you.
Thank you.
Thank you.
Bye.
Yeah, bye. Thanks all. Bye.
Bye. Uh-oh. Let's watch this.